Okay, welcome to lesson 8 and it's a continuation of the graphs of trig functions lesson. So learning target 9 is actually determining the equation given a sine or cosine curve. So if you're given a curve like the ones given to you, these are really the examples we did in the previous lesson, coming up with the equation. And so some of the things we've already talked about, like we talked about the axis, like you can take the max plus the min, divide by 2. So you get y equals 11. That means, and so we just draw that axis there because it helps us really see the amplitude. So we state what the transformation is because that'll help us decide how we put that into the equation. State the amplitude, which is 8, so that distance there is 8. And that's a vertical stretch by a factor of 8. So we put it where we see vertical stretches. The period's 180, so the length between what we saw is 140 and 320 is 180. And that's the best place to read it is with the points that are right on the graph. That's a horizontal stretch by 1 over k. A period of 180, a k value would have to be 2. And so it's a horizontal compression by a half. And so we can see that by dividing 360 by 180. A sine equation would start with f of x, obviously, but if you can lead off with the vertical stretch factor, and then we're going to use sine 2. But now we look at like where we're going to use x minus 95, and that's because this line here is 95. That's not that easy to estimate, and also this is probably a more challenging question. But the sine curve has to start on the axis and going up. And so the point that starts on the axis and going up is when x equals 95. So we've shifted the base graph to the right 95. That's why we've got this minus 95 here. The way we got the 95 is if you cut the 180 into 4 parts, you get 45. And if you look here and you can see that this is 140, that's where you get the 95 from, because this is every 45 degrees you have to hit a max 45, 45, 45, and 45. And so to use the period of 180, the quadrants are all split into 2, which is 45 every time. And that's really where the 95 is coming from. Then we have to add 11 to get that vertical shift. Cosine would start at the top, so our shift is going to be a little bit different, but our amplitude stays the same, our k value is the same, period still stays the same. But we're doing x minus 140, and so the graph actually starts here. It should really have another dotted line, but the graph starts here to the right 140 from the y-axis, and we're adding 11. Okay. Next example, we start with the axis again, and we can see that the average between 3 and negative 13 is negative 5. That's a vertical shift down 5. The amplitude is the distance between the min and the midpoint, or the max and the midpoint. It's not really a formula, but it's just like if you say 13 minus 5, you get 8. So it's just counting the points from here to here, or the points from here to here. We get 8. So that's a vertical stretch by a factor of 8. The period 720, you can see from the max to the max, we got 720. So that's a horizontal stretch. This is a stretch now by 1 over k. And so the k value is actually still found the same way, even though it's a stretch. If we do 360 over 720, we get 1/2. So possible sine equation would be, again, starting at 8, because you get the amplitude, the vertical stretch factor. We use sine of a half. And then because it's a sine curve, we're going to shift it to the left 180. So sine starts here and goes up. So we're going to shift the base graph to the left 180 degrees to get it there. And so so you can almost see, if you pretend that this is the xy axis, you can almost see your sine curve right there. And then we got to subtract 5. Okay. Very similar for cos. The 8 and the half stay the same, except the shift value is a little bit different. Here we can start right on the x-axis, or on the y-axis, and the cosine graph starts at the top going down, so there's no need for a shift here. And so we subtract 5. Couple notes, for a sine curve you need to be on the middle line going up or down if you're vertically reflected. And for cosine it needs to be on the max or the min if vertically reflected. So you have to shift it left or right. And that's probably the most challenging part about this. Okay, the next one, the axis is 3. So you can see that horizontal line through y equals 3. And you got a vertical shift up 3. The amplitude is a half. The distance from the horizontal line to the max or to the min is a half. So you got a vertical compression by a half. So you have to have that in your equation. The period is 90. So from start to end, it takes 90 from start to end. So that's a horizontal compression by 1 over k, which is 360 over 90. So I have a k value of 4 for the horizontal compression. It's a possible sine equation, and I noticed that like these are a little bit off, but just for simplicity, we're gonna pretend that these are right on 90. Really, that was the intention, but the graph got a little bit off. So if you wanted to shift it to the right a little bit more, you could, but we're gonna pretend that this guy starts right on the axis and then ends right there on the axis at 90. Even though I see it's a little off. So the sine equation is going to have an amplitude of a half, and we're going to use sine 4x. We actually use a negative because there's, as I said, if you don't incorporate a horizontal shift, it's just it's starting on the middle line and going down. We still have to have that plus 3. The cosine graph looks similar, but cosine graph would have to start on the max or the min. So we're actually going to break 90 up into 4 parts and shift it to the right at 22.5. We actually use a negative cosine curve to say that we're starting on the bottom and going up. Okay, we'll still have the plus 3. So again, notes on the vertical reflections. So sine starts going down, cosine starts at the minimum. And there's practice questions.